The following handout can be found in Canvas. This activity 5.5.6 part 2 is not in your book, but I did post this document in Canvas, so you can print this out and work alongside me. Okay. So what we're going to do is we're going to solve rational equations, and we're going to do it algebraically. All right, it says the steps are simplify each side of the equal sign, cross multiply, and then solve. Okay. You know we could always graph the left side of our equal sign as y1 and the right side as y2 and find the intersection on our calculator. But we're not going to focus on solving graphically. But I just want you to know that you could check your work graphically. Again, you graph both sides of the equal sign and get the intersection. All right, so let's take a look at example 1 algebraically. My first step will be to cross multiply. So you'll see we'll do 3 times x to get 3x and 4 times the quantity x minus 1. Step 2, I'm going to distribute this 4. So we're left with 4x minus 4. Next, I'm going to subtract 4x from both sides to get the variables to one side and numbers to the other side. So here's me subtracting 4x from both sides. And then I'm going to be left with negative x equals negative 4. And of course, we can't leave our answer as negative x, so I think I want to divide both sides by negative 1. All right, so here's me dividing both sides by negative 1 to get our final answer, x equals 4. All right, so the solution to this equation, right, or the value of x that makes the left side equal the right side, is x equals 4. And again, here is all of the work. Right, so we've solved this equation algebraically. Let's take a look at example 2. So of course my first step will be to cross multiply. Right, I'll do 1 times the quantity x plus 1 and 2 times the quantity x minus 1. Then we're going to want to distribute the 1 and we're going to want to distribute the 2. So this is what we have after we distribute the 1 and we distribute the 2. Next, we're going to want to combine like terms, right? We're going to want to get the x's to one side and the numbers to one side. And I think I can achieve this by subtracting x from both sides first. So you can see I'm going to be left with 1 equals x minus 2. And now if I add 2 to both sides, I can solve for x. So it looks like I'm left with x equals 3. So the solution to this equation, or the value of x that makes the left side of the equal sign equal to the right side, would be x equals 3. And again, you could always check your work by graphing y1 is 1 over x minus 1, and y2 is 2 over x plus 1, and get the intersection, right? You graph the left side of the equal sign as y1, the right side of the equal sign is y2, and the intersection would be your answer. Let's take a look at example 3. So of course we're going to start by cross multiplying. Right, so we did 1 times 3 is 3, and x times the quantity of x minus 2. Right, we're cross multiplying. Step 2, we're going to distribute this x. So we end up with an x squared minus 2x. Now because of this x squared minus 2x term, I think if I subtract 3 from both sides, we might have a quadratic equation that I can factor. So step 3, I'm going to actually subtract 3 from both sides. And when I finish, the result will be a quadratic in the form of ax squared plus bx plus c. And again, I think we're going to be able to factor that. So we've moved the 3 over. And now I'm going to try and factor this x squared minus 2x minus 3. Okay, so this is how this factors, right? Remember, you're asking yourself, what two numbers when multiplied give me negative 3? That's the negative 3 times 1. But when I add those same two numbers, I need to get negative 2x, so that's negative 3 plus 1. That gives me my negative 2. So my final answer is actually going to be x equals positive 3 and x equals negative 1. So I'm left with x equals 3 and x equals negative 1 as my solution. So I guess what we're saying is if I put in negative 1 for x here and here, both sides will be equal. If I put in a positive 3 for x here and here, both sides of the equal sign will be equal as well, or both sides of the equation. All right, last example. Let's try example 4. So example 4 is a little bit different, right? Because notice we have 3 terms here. With all of the other equations, it was just a direct proportion. But if you notice, we have the same denominator. So my first step would be, okay, well, if I have the same denominator, I can do the addition or subtraction across the numerator. So 4 plus 1 is 5. So I'll be left with 5 over x plus 1. All right, so that's what it looks like, right? The right side, nothing changed. But on the left side, we did 4 plus 1 to get 5, and it's all over my common denominator. Now we can get ready to cross multiply. But before we do, and you don't have to do this step, but I wrote negative 1 as a fraction. I wrote it as negative 1 over 1. Just so now you can really see when we cross multiply, it's 5 times 1 and negative 1 times x plus 1, the quantity. So then we cross multiply in step 2 to get step 3. Right, and now step 4, I'm going to distribute this negative 1 all the way through, and I'll multiply 5 times 1. So here's step 4 where I distribute the negative 1. In step 5, I'm going to add 1 to both sides because I'm going to try and get the x by itself. So from step 5 down here in the bottom left, I'm going to go to step 6, right? When I add 1 to both sides, I'm left with negative x equals 6. And of course, we can't leave this negative x. So I think if I divide both sides by negative 1, I should be in better shape. So here's me dividing both sides by negative 1. And step 8 will give me my final answer. I'm left with x equals negative 6. So again, if I place a negative 6 in for x here, and I do the math, or the algebra, I should get negative 1 equals negative 1, right? This is the value of x that will make the left side of my equal sign equal to my right side. Thank you for watching.